Hi everyone and welcome back. In today's lesson we are going to learn about the inverse of an exponential function. We are going to learn how to determine that inverse as well as how to draw it. So in the graph below they tell us that the graph shows the following function: fx is equal to 2 to the power of x. Now let's quickly make sense of all of this. So if we look at this function, we know that the coefficient is a positive 1. Just because we don't see it doesn't mean it's not there. The base is a 2, the exponent is an x, and that is how we know it's an exponential function, because x is an exponent. And then plus q, just because we don't see it doesn't mean it's not there, it will be a plus 0. So we start with that. So if I go to this function, we know that the horizontal asymptote will be right on our x-axis and go through our y-axis at 0, and there it is. And I can write the equation of that horizontal asymptote as y is equal to 0. Now again, this is very important because this is the line that our exponential function cannot cross. Now we go and look at this coefficient. It's a positive 1, and that is why the graph is above the asymptote. Then the next one, this base, this value is greater than 1, and that's why this exponential function from left to right slopes away from the asymptote. Okay, so now that we know all of that, we can determine the inverse and then draw the graph on the same set of axes. That is actually what we need to do. So I'm going to write down our original function as fx is equal to 2 to the power of x. And you know from our previous lessons, if we need to get an inverse, we need to swap the y and the x around. Remember, fx is y, so in the place of y we're going to write x, and in the place of x we're going to write y. And there it is. And now we have to rewrite this equation so that y becomes the subject of this formula or this equation. So I'm going to write down y is equal to, because now it is the subject, and we are going to introduce logs. So I'm going to write here log, and look at how we are going to write it. Since this 2 is the base of this exponent, it becomes the base of the log, and there it is. And this x, which was the subject of the formula after we swap the x and y around, that x gets written in front of the log, and there is our inverse function. So now we can rewrite it quickly. So therefore our inverse function is equal to log to the base 2 and the x at the front. Okay, so there it is. Now that we have the equation for our inverse, it's easy to go and draw it. Now let's quickly have a look. You remember from our previous lessons that I mentioned that an inverse is basically our original function's x and y coordinates swapped around. So if our horizontal asymptote was plus 0, our equation was y equals 0, right? So that means if we change the y to x, x equals 0, then our inverse asymptote is on our y-axis, goes through our x-axis at 0, and its equation is x is equal to 0. Got it? Okay, excellent. Now here we had the y-intercept of our original function. If we swap these coordinates around, well, we get the x-intercept of our inverse function. Now all that we need to do is get some other points to draw it correctly. So I'm going to open up a table. I'm going to write x and y. And we already did the first one where I take this 1, put it in x's place, and we know that the y value will be a 0. Okay, then I'm going to choose an x value of 2. I'm going to put it in x's place. I'm going to do the math on my calculator, and you will get a y value of 1. And we can simply go and plot that pair right over there. And then I'm going to choose an x value of 8, and I'm going to put it in x's place, and I'm going to get a y value of 3. So we can go and we can plot that pair, and it will be right over there. Now I can connect these points, and there we go. And remember, this is our asymptote, so our graph cannot cross it, and there we go. So now you can easily see that an inverse is a reflection in the line y equals x. So there is our line y is equal to x. So it's the mirror image if this is the folding line. So you can see that our original function is the mirror image of this inverse if we fold it on this line y is equal to x. Now don't despair, there's also another easy way to do it. If you have the original function, you can easily draw the inverse by simply choosing your own x value, put it in x's place, get its y coordinate, and if you swap those two coordinates around, you've got the coordinates of your inverse. Now we are done. Now, just before I end off this video, some of you might wonder why there is no inverse video on an hyperbola. Well, because an hyperbola is its own inverse. There is no other form for it, so that's why there's no video on the inverse of an hyperbola. See you again next time. Bye.